So in the last video, I gave a bit of a warning that this one contains slightly crazier examples than the previous one. And in fact, I wouldn't go, these are as hard as you could possibly see at higher level would be the two examples in this video. So don't panic if you are like seeing stuff and you're thinking that looks really, really tricky. Most of what you're going to see is very like what you had in the last video, but there is no reason that you couldn't be asked about a range which goes from minus 270 to 540. It's a bit arbitrary, but it is totally valid. So we are going to have a go at solving this. We're going to start in our normal way. We're going to do an inverse cos. That is going to give us an angle which is 53.13 degrees. It's worth noting that's also our relative acute angle in this case because we're working with a positive trig equation. Rush through this section a wee bit because you've seen it so many times, but we'll sketch ourselves a graph. We've got one angle there, we've got one angle here. So this one along here, well, if this bit is 53.13 degrees along, this bit is 360. Take away 53.13 degrees. And that is going to give us, and you can just put it in a calculator, 306.87 degrees. So far, so good. Nothing out of the ordinary. You could get there via cast. Where is cos positive? Well, there and there. Well, this is our relative acute angle. And this is 360, take away our relative acute angle. So exactly the same result. So nothing weird there. What we do need to just think about is how we're going to get things in this range up here. So cos repeats every 360 degrees. So what have we got? Well, we could have this plus 360 degrees. So 53.13 plus 360. And we can find out what that gives us. Well, that gives us 413.13 degrees. That's fine. That's still less than 540. So that's definitely a valid value. Next one, let's do 306.87. And add 360 to that. Well, that gives us 666.87 degrees. That's a problem because that is bigger than 540. So it's worth just noting down that this one is fine. This one is out of range. If you keep a good eye on that as you go, it will save you making any mistakes when we write our answers at the end. Now, we also have in our question this thing of negative angles. Well, none of our angles are negative so far, but instead of going forwards by 360 degrees, we could try coming back by 360 degrees. And even just sketching our graph on gives us a sense, actually there's going to be a value about here, and there's going to be another one over here. So actually, yeah, there's hope that we might be able to find some in this range here. So let's have a look. What are they? Well, let's try taking 360 away from our different values. So let's do 53.13, take away 360. We can do 306.87, take away our 360. And we can find out what we've got. So first one there, if we do 53.13, we get minus 306.87. Well, that's no good because that's outside of our range. We only wanted down to minus 270. So that one is out of range. This one here, on the other hand, gives us minus 53.13. No, it doesn't. Yes, it does. Sorry. So that one works nicely. So actually, try them. If you get things that are out of range, that's not a problem. Just note it down. Be aware of it. You've only spent a moment figuring one out that is not required. So what are our answers? Well, our answers are, well, this was the solution to the equation because it wasn't a negative, so we can have this one. So that's 53.13. Or what have we got? Well, this one worked. Sorry, this one worked. So that was 306.87 degrees. We had no problems with the 413 one. That was in range. And finally, the minus 53.131 was in range. We don't include these two because they are out of the range that we're interested in. So there is our final answer. As I say, that's about as hard as it can get because you've got negative bits in our range, and we've got several angles to concern ourselves with, and sometimes we go out of range. So it's got kind of all the different elements you might experience in a kind of worst case scenario. Second example that we are going to do involves something a bit different. So it's not got a ridiculous range, but it does require us to work in a wider range when solving in radians this time. So how do I know it's radians? Well, I'm going up to 5 pi here. So 5 pi, anything in pi's gives us a clue we're solving in radians rather than in degrees. There's no degrees sign as well. That's the other clue. Now it's positive, so we can just do a straight tan to the minus 1 of 1. And that gives us, now this is an exact value, and if you use your calculator, most of your calculators will churn out your exact value, but it's good if you start to learn to recognize them. For tan, we get exact values at root 3, at 1 over root 3. So those are the ones to watch out for with tan. Looking back in your notes, you'll find that's pi on 4. And because it's a positive, that is also a relative acute angle. We haven't had to change any signs there. Working with our graph gives us some values. So where is 1? Well, let's call that 1 on our tan graph. Crosses there and there. That's pi over 4. This is pi. So we can see the section from 0 to pi on 4 is exactly the same as pi along by another pi on 4. So here we're doing pi plus pi over 4. We get exactly the same result if we used our cast diagram, because we've got tan being positive, which happens up here and here. Well, this is our relative acute angle. This is pi. So this, to be in this section down here, is pi plus our relative acute angle. So that gives us exactly the same thing as we had here. Now, what we're going to do with that, I might actually take a new line. Well, how many over 4s do we get? Well, it's the same as 4 pi over 4 plus pi over 4, which is 5 pi over 4. So by turning this into quarters of pi, we can add them together nice and easily and get 5 pi over 4. Now, this is where we need to think slightly differently. Tan repeats. It does repeat every 360 degrees, but we're working in radians here. So we might want to write that instead, because we can't add on 360s to this and get sensible answers. It only makes sense if we keep working in radians. So we're adding on lots of 2 pi. We have forgot this angle plus 2 pi, this angle plus 2 pi. So let's see what we've got. So we could have pi on 4 plus 2 pi's. We'll figure that out in a second. We could have 5 pi on 4 plus 2 pi's and see what we get. So that one there is going to give us, well, 2 pi is the same as, well, if I want it over 4, what over 4 gives us 2? Well, 8 over 4. So that's the same. So pi over 4 plus 8 pi over 4 is 9 pi over 4. Doing the same down here, we end up with 5 pi over 4 plus 8 pi over 4. And that gives us 13 pi over 4. Now, it's easy to stop at this point, but it's important we go back and we check our range. That was 0 to 5 pi. Now, 5 pi if we change it to a fraction over 4, so times the top by 4 as well, we get 20 pi over 4. Now coming down, we've got things that are definitely less than 20 pi over 4 here, but could we find any others? Well, the only way to check that is try adding some more pi's onto this. So let's try that. Let's do 9 pi over 4 plus 2 more pi's. Let's try doing 13 pi over 4 plus 2 more pi's. So this is when you just always check bigger. If it's out of range, no problem, doesn't matter. So let's check that. 9 pi over 4 plus 8 pi over 4 is 17 pi over 4. Ah, that's still good. That's still less than 20 pi over 4. So we can include that one. 13 pi over 4 plus 8 pi over 4 is 21 pi over 4. That's now too big. That's out of our range. We were only going up to 20 pi over 4. So that is not going to get included. So again, we're going to list our answers. Sorry, I'm running out of space at the bottom here, but our answers are, just reviewing, going back up my page, I had 5 pi over 4 worked, 9 pi over 4 worked, 13 pi over 4 was fine, and 17 pi over 4 was fine. So that again is a bit of a harder example because our range goes beyond just adding 360 or 2 pi one time. It is also a bit tricky because we're working those radians, and so we have to think carefully with that. Hopefully, as we work through more examples, you'll get used to what to expect, how many answers to expect, how many lots of 2 pi do we need to keep adding on. That will become more natural the more you practice. So have a go at the questions, but also be checking your answers as you go through to make sure that you're kind of on the right lines, you're getting enough answers, you're not missing answers out as you go through. So hopefully that gives you enough to get going on the questions, and then we will be picking up on task 2 with a slightly different adaptation to our solving trig equations skill.